All right, only a couple more videos to do and then the tests and you are done. But let's start with a few common integrals, which aren't really to say they're that common, but just ones that we expect you to be familiar with or kind of know rather without having to work it out too much. But if you have the integral of something like a over x, then it will integrate as a times the natural log of x. The derivative of the natural log is 1 over x, so the integral of 1 over x would be the natural log. A is a constant, so we can just factor it out. The integral of e to the x is e to the x. And again, these are just the reverses of the common derivatives that we went over. So e to the x's derivative is e to the x. The integral of e to the x is e to the x. A few of the trigonometric ones, the integral of sine is negative cosine because the derivative of cosine is negative sine. The integral of cosine is sine. The integral of cosecant cotangent is negative cosecant. The integral of secant squared is tangent. Again, you can see we're just following the derivative rules in reverse. So the integral of cosecant squared, negative cotangent, and the integral of secant tangent is secant. Up here, I added a couple more that kind of combine the two. So the integral of the tangent of x is the natural log of the absolute value of the secant of x. And that is found by using u substitution. So we know tangent can be written as sine over cosine. If we let u equal cosine, the derivative is negative sine. And so what we end up with is negative the natural log of the cosine of x. And then they move the negative up to the power. So a lot of algebra going on there to simplify that, but you get this nice rule here. The integral of secant of x is equal to the natural log of the absolute value of the secant of x plus the tangent of x. They're a very similar formula that we did to tangents. U substitution, a little bit of breaking this down into 1 over cosine, and then algebraically manipulating that. A little bit more involved, but. So the exercises that this video will cover are the common integrals of e to the x and natural log of x, the common integrals of the sine, cosine, the trigonometry, and then the definite integrals of common integrals. So we're going to look at those. And again, just example problems, really, it's just using this list. So I'll kind of show you how it works out, but nothing too bad. All right, so here, common indefinite integrals, e to the x and natural log x. So we have this. And to get an idea of how we're going to work this, we're going to break up the integral. So it's the integral of 5 over x dx plus the integral of e to the x dx. And then we're just going to do each one of those. So 5 over x is that natural log form. So I know that's going to be 5 times the natural log, the absolute value of x. That's just e to the x. And then plus c for good measure, and then we just have to match that up. That is b. And that's really it. That's all you're doing, is using those common integrals. Let's see what the next one is. Same thing. Remember, constants don't actually affect the integral. You can factor them out. So this is going to be 2 times the natural log of the absolute value of x minus 4 e to the x plus c a. So just like that, over and over, using the integral of the natural log of x and the integral of e to the x. Let's look at sine and cosine. So a little bit of the trigonometry. Obviously, we would like you to know more than just sine and cosine, but that's okay. So here, we have the integral of 4 sine x dx. I'm going to use a property of integrals to factor out the constants. And then I know, well, the integral of sine is negative cosine. So that's 4 times negative cosine x plus c. And then we just multiply. So it's going to be negative 4 cosine x. And just sine and cosine, I want you to know the other common integrals, but this particular exercise is just sine and cosine. So we go negative 4, and I guess we just type in cosine x. Cosine x. And see if that checks off. Good. And then the other one, negative 5 cosine x, again, same thing. Factor out the constant if you want. Integral of cosine, write it there. So that shouldn't take you too long either. Last exercise is the definite integrals of common functions. Common functions, a to the x, e to the x, natural log x, sine x, cosine x, polynomials, things like that. Let's see what Khan Academy focuses on here. So, evaluate the definite integral from 0 to 1, negative 12 e to the x. Well, the integral of that is negative 12 e to the x, evaluated from 0 to 1. So we would then do f at b minus f at a. So we would have negative 12 e to the first minus negative 12 e to the 0, which would end up being just negative 12e plus 12. So we would look for that one. Negative 12e plus 12. I'm going to have to scroll down. And there it is. It's c, negative 12e plus 12. Okay. This one doesn't look like a common integral yet, but we can simplify this expression a little bit. It's definitely not fully simplified, so let's look at that. Let's take our x to the 6th minus 25 x to the 4th over x to the 6th. Now, in algebra, a lot of times we want to push expressions together so it's a single item that we have to work with. So everything is kind of contained in one expression. But for calculus, because the derivative and the integral can be performed term by term, a lot of times when we're dealing with something like this, we want to break it up as much as possible into as many simpler terms. So with derivatives, we had logarithmic differentiation to take the log and break everything up by properties of logarithms to do that. For integration, we don't have logarithmic integration, but this we can simplify just by decomposing the fraction. For integrals, you have integration by partial fraction decomposition, which we did not cover and will not be covering, but that would be similar. But we want to break this up. I digress. I'm sorry. I want to break this up, so I'm going to rewrite it, decomposing the fraction. X to the 6th over x to the 6th, and then minus 25 x to the 4th over x to the 6th. And then I'm just going to integrate both of those terms. Well, x to the 6th over x to the 6th is 1. And this is going to be 25x to the negative 2 dx on both of those, so I can get the reverse power rule. But that's pretty simple. The integral of 1 is x. or whatever variable you happen to be working with, but we're using x. Dx is right there. 25x to negative 2, following the reverse power rule, I'm going to add 1 to the power so that it would be x to the negative 1. And then I'll divide by that. So 25 divided by negative 1 would be negative 25 minus the negative 25 ends up being plus 25. So the integral is x plus 25 over x, evaluated in this case from negative 5 to negative 1. So once I have that integral there, all I have to do now is simplify, or excuse me, not simplify, evaluate by f at b minus f at a. So we're going to do f at negative 1, which would be negative 1 plus 25 over negative 1. And then f at a, which in this case negative 5, would be negative 5 plus 25 divided by negative 5. And both of those are pretty easy to evaluate. That's negative 1 minus 25, so negative 26. And then minus negative 5 plus a negative 5, which would be negative 10. So I have negative 26 plus 10, it's going to be negative 16. And so that's what I put in. Negative 16. The negative telling me that the displacement of this curve from the x-axis, it is below the x-axis in this interval, and the 16 telling me the square units that it actually takes up in that region. And the rest of them work just like that. You may need to simplify. It may be sine or cosine or e to the x, natural log of x. But these should be relatively common functions that you're used to, and just getting used to that definite integral. Once you have the integral, remember it's f at b minus f at a. Tune in next time for u substitution. And then last, we'll do the separable differential equations. But remember, I'm not going to test you on that. Your last test, the third one for this 9 weeks, will be just on the integration stuff. Reverse power rule, the common integrals, definite integrals, and then u substitution. And that's it. You will have completed all of the assignments for calculus, and those tests should be up tomorrow. All right, see you next time, guys.